equation of the tangent line to the curve at x equals -1. Find the coordinates of the minimum and find the coordinates of the points of inflection. So find the coordinates means that I need to find both the x and the y value. So first we're going to find the equation of the tangent line. So to find the equation of the tangent line, I need to find the derivative. I'm not going to set that equal to 0 because I only set it equal to 0 when I'm looking for critical points or when I'm finding maximum or minimum. I want to find the slope when x is -1. So this is my slope. So how do I find the slope when x is -1? I am going to substitute -1 into my x value. I'm going to have -4 plus 12 which is 8. And that is the slope of your tangent line. So notice I didn't set it equal to 0. So now I need to find a point to find the equation of my tangent line. I know what x is. X is -1. So I need to find y. So to find y, I'm going to substitute it into my original equation. So I get 5. So I have my slope. I have my point. So now I can write my equation of my tangent line. So y minus 5 equals -1 x minus 8. Part B says, find the coordinates of the minimum. So to find the minimum values, I have to find the derivative and set it equal to 0 and find the critical points. And the critical points occur when the derivative is equal to 0 or the derivative does not exist. I already have the derivative from part A, so all I have to do is set that equal to 0 and solve for x. So I'm going to factor out a 4x squared. So I'm going to have 4x squared equals to 0, or x plus 3 equals to 0. So x equals 0, x equals -3. So these are my critical points. There's going to be no place where the derivative does not exist. So I'm going to check. I'm going to check the sign of the first derivative because I need to see whether my first derivative is positive or negative. So I'm going to check the one that's already factored. Notice that 4x squared is always going to be positive no matter what number you substitute in. So I'm just going to be worried about the x plus 3. So a number to the left of -3 would be -4. So -4 plus 3 will give me a negative. From -1 to 0, try -1. -1 plus 3 is positive. And the number to the right of 0, 1. 1 plus 3 is positive. So once I check those numbers, remember I don't need them anymore, so let's not use them. So I have a minimum value. Okay. My x value for a minimum is -3 because I'm going from decreasing to increasing. So that is my x value. But because it's asking for the coordinates, I need to find the y value. So the way I find the y value is I have to substitute that into my original equation and find my y value. So -3 to the 4th power is going to be 81. And 3 to the 4th to the 3rd power is 27, and 27 times 4 is 108. So 81 minus 108 would be -27. 12x equals to 0, x plus 2 equals to 0. So x equals 0 and x equals negative 2. So these are possible points of inflection. So I'm going to do my number line to check whether they are points of inflections. And I need to check, since I'm looking for points of inflection, the sign of my second derivative. So I'm checking the sign of the second derivative. So I need a number to the left of negative 2, so negative 3. So 12 times negative 3 is the negative. Negative 3 plus 2 is the negative. So negative times the negative is a positive. The number between negative 2 and 0 is 1. So 12 times negative 1 is a negative. Negative 1 plus 2 is a positive. So that's going to be a negative. 12 times 1 is positive. 1 plus 1 is positive. So that's going to be a negative. So once you're done checking, erase those points. You don't need them. So my coordinates for my points of inflection, or my x-coordinates, are negative 2 and x equals 0. Since they want the coordinate, I have to find the y value. So I'm going to substitute that into my original equation. I need to substitute both points into my original equation. So 2 to the 4th power is 16, and negative 2 times to the 3rd power is negative 8, and negative 8 times 4 is negative 32, and 16 plus negative 32 is negative 16. So one of my points is going to be negative 2, negative 16. The second point is going to be 0, 0. The next problem says the graph of the function is shown below. Which of the following could be the graph of the derivative? So we're given the graph of the original function. So this is my original function. And we want to know which one's my derivative. So remember, the derivatives, when the derivative is equal to 0, so the x-intercepts of the derivative mean that is the maximum or minimum of the original function. So notice that I have 2 minimums and 1 maximum. So those are zeros. So that means that if I look at my derivatives, I'm going to have 3 x-intercepts. So I know that it can't be a because I only have 2 x-intercepts. Can't be d. Can't be b because notice I only have 2 x-intercepts. So the only options I have is c or e. Both of them have 3 x-intercepts. So the next thing I'm going to do is I'm going to look at the slopes of the line. So notice that from negative infinity to this point, my slopes are negative. So that means my function is decreasing. So that means that my derivative is going to be below the x-axis at this point. So notice here, I'm below the x-axis. Here, I'm above the x-axis. So by elimination, my answer has to be E. But let's look at the graph so you can see how this works. From this point to this point, my slopes are positive. So that means I need to be above the x-axis. So notice how I'm above the x-axis. I'm decreasing, so I need to be below the x-axis. And then finally, I'm increasing, so my slopes are positive, so I need to be above the x-axis. The next problem says, for what values of x is the graph concave upwards? Well, in order to find whether it concaves up or down, I have to find the second derivative and set the second derivative equal to 0, or find when the second derivative does not exist. So I'm going to find my first derivative, So I'm going to have 2x over 2. And I'm going to rewrite this as 4x to the negative 1. So it makes it a little bit easier to take the derivative of. So I have negative 4x to the negative 2. And notice these are going to cancel. So now the second derivative is going to be 1 plus 8x to the negative 3. So I'm going to set my second derivative equal to 0. So I get 8 over x to the third equals to negative 1. Cross multiply. So I get x equals negative 2 because I need to take the cube root of both sides. So that is a possible point of inflection. So now I'm going to check the sign of my second derivative because I need to check whether the second derivative is positive or negative. And that's going to determine whether my function is concave up or concave down. So my second derivative, so I need a number to the left of negative 2, so let's do negative 3. So 8 over negative 3 to the third is 8 over negative 27, and it's 8 over negative 27 smaller or bigger than 1? It's going to be smaller, so therefore A is positive, so this is positive. Okay, one other point that I forgot to see is, remember that the second derivative, the points of inflections are where the second derivative is equal to 0 or the second derivative does not exist. Well, notice that I'm going to have a point where the second derivative does not exist, and that's going to occur when x is equal to 0. Because if I have 0 here, I get a 0 in the denominator, so that is also a possible point of inflection. So I need a number between negative 2 and 0 to negative 1. So 8 over negative 1 to the third is negative 8, and 1 minus 8 is going to give me a negative number. So let's use 1. So if I substitute 1 into here, I get 1 plus 8, which is positive. All right, so if you notice of your second derivative, I'm going to be concave up here, concave down between negative 2 and 0, and concave up in this interval. So remember, once you're done checking the numbers, get rid of those. Don't use those as your answer. So it says, where is my function concave upward? It is concave up between negative infinity and negative 2, and 0 and infinity. The next problem says, find the absolute minimum value on the closed interval. So the absolute minimum value of f of x on the closed interval occurs at, so to find the minimum value, I have to find the first derivative. And set that equal to 0 to find my critical points. So I'm factoring out as 6x. I get 6x is equal to 0. X plus 3 is equal to 0. So x is equal to 0 and x is equal to negative 3. Okay, so those are possible points of max or min, they're critical points. But because I'm looking for the absolute, I'm not going to do a number line. Okay, so I'm not going to do a number line. I do a number line if I'm checking for local max or min. Since I'm looking absolute, I have to check my endpoints at wow. So I am going to do a table. I'm going to have -5, -5, -3, 0, and 2. And I'm going to substitute that into my original function to find out what my y value is. Now, remember, I don't have a use of a graphing calculator or a calculator with me. So I'm going to try to estimate these numbers to see which one's the biggest and which one's the lowest. I actually just need to find which one's the lowest. So I'm going to have 2 to the -5 third plus 9 times -5 squared minus 10. So that is going to give me 2 times -125 plus 9 times 25 minus 10. Okay, the next one's going to be 2 times -3 to the third plus 9 times 3 squared minus 10. So 2 times -27 plus 9 times 9 minus 10. Okay, when it's 0, that's -10. And then 2 times 2 to the third plus 9 2 squared minus 10. So it's 2 times 8 plus 9 to the fourth minus 10. Okay. So far my lowest number is -10. So I need to figure out if any one of these is going to be smaller than -10. Will you notice when -3, 2 times -27 is -54 plus 81 minus 10. Well, 81 is larger than 54 minus 10. So that means this is going to be a positive number, so it can't be -3. Here I have 16 plus 36 minus 10, which is still a positive number, so I know it can't be 2. So notice how I'm eliminating. I'm eliminating because I don't have a graphing calculator to just put this in and figure what the values are. So I just have to look at -5. So 2 times -125 is going to be -250 plus 9 times 25 minus 10. So I'm going to have -260 plus 225. So is that going to be bigger, smaller, or larger than -10? So it's going to be larger than -10. So that means -5 is my absolute min. So that is where it occurs.